With us this evening, Matthew is joining us, and many of you may remember him from his presentation on high altitude ballooning, which is up on our YouTube. If you haven't had a chance to check that out, it's a very, very cool project, and he gives a great talk on how that was implemented and his progress on that using the Helium network. So make sure to check that out. Thanks for joining us, and I'll go ahead and pass the mic over to you and let you, fill us in on what the new stuff you're working on is.
Thanks, I appreciate it. So besides being someone who's really interested in helium, I don't have any hotspots. I'm 100% a user of helium rather than a miner. But I believe that being a user of helium is also a really powerful way to create wealth, and that can be in any number of dimensions. For me right now, it's research. I I got involved in helium because I use it for high altitude balloon telemetry, which you can see our other conversation about that, which is on YouTube. And what I had today, which I wanted to show you, was sort of an idea that I came up with a couple days ago and actually implemented last night, at least partially. Basically, it's the marriage of two things which I find really interesting. One of them is amateur radio. I've been an amateur radio guy for a number of years now, and the other is helium. And these are not normally things that you would think are compatible or really related, besides the fact that folks with an interest in one likely will encounter the other, and maybe there'll be an interest in both. But ham radio has a number of different properties that make it it's a family of technologies with vastly different goals, right? In amateur radio, usually we're interested in moving analog voice from place to place. It's never done with interest towards business applications or generating profit. Encryption is something which is actually not allowed in amateur radio. So at first glance, you'd think there's not a lot that we can share between these two technologies, but I want to show you quickly that there actually is, and it might be really beneficial to both groups in order to have these conversations and sort of swap ideas. So what I have to show you over here is a typical handheld amateur radio transceiver. This is my Kenwood THD72. It's an analog machine, and what it does besides FM voice is it has a built-in packet radio engine, which can transmit over a system called APRS, which is the automatic packet reporting system. Okay, so what's that? APRS is ham radio technology. It's been around before the internet. I'm not 100% sure the exact time and by whom it was invented, but decades and decades this thing has existed. Prior to the 90s, it was in its mostly modern form. And what it does is it's a way to take your analog FM ham radio transmitter and send a short packet of information over a system and have it relayed to other users. Nowadays, there was sort of a packet radio heyday in the 90s, back with BBSs and other old school but really cool things that people signed on to. Nowadays, APRS is, I'd say, 95% used to send these packets from remote places and get them forwarded to a map on the internet. If it's all right, I can show you. I'll actually share my screen here, and I've got a live view of this system right now. So can you guys see this? This is a view of where I am and the APRS activity at this particular instant in time in the city of Calgary. So the deal here is that you see a couple of objects. These are people who have ham radio transmitters, which are sending their packets, and they're being received by dedicated receiving stations, sort of an old school equivalent to a helium hotspot, I guess, and forwarded to this internet system. This website is the most popular, aprs.fi, but there are others, and it connects to a big decentralized infrastructure, which is online for handling and forwarding these packets. The point is that the main use case for this is that this guy, for example, who's beaconing where he's driving right now, he is sending packets he says what frequency he's monitoring, and you can see that his packet is being picked up by one of these stations up on Pigeon Mountain over here, which is a couple thousand feet tall. So what happens is he sends out his packet on VHF on this agreed upon frequency. It gets received by this, the word they use is digirepeater, which reads the packet, parses it, and retransmits it to everybody else on the network. And then once it's retransmitted, it eventually finds its way to the internet through one of these, which is called an iGate, internet gate, and then ultimately finds its way to this site. So everybody on this map is either a part of the infrastructure or they are a user of the network. You can see a lot of weather stations too, and they're sending out packets usually once every 2 minutes to once every 10 minutes with the description that the creators of APRS like to use is tactical information. So not exactly real time, but to give you a sort of tactician's overview of the layout of all the resources on the map that updates frequently enough. So what I thought was kind of interesting is I've been a user of this system for a long time, and it's excellent at what it does. And it's a resource that a lot of people in the amateur radio community are familiar with and use. One of the main ways which it is used is publicly sharing information like this. For example, this is a traffic accident or an advisory, I think, that someone has uploaded to the map over there and is being forwarded to everybody on the system. And there are a couple of other things like that on the map. I believe down here there are some forest fires which are tagged, but you get the idea. If you go to a more populated location, you can actually see the trail that people are following as they send out their packets and where they're being received. Okay, so that's what APRS is. That's what it does. It's an analog type modulation over voice FM on a agreed upon frequency, which changes per country. And there's this aspect of it which forwards things to the internet. So how does this tie into Helium? What Helium is really, really, really good at, in my opinion, as a user of the network, is the following. If you look at this map and you see the green star icons, there's one here, one here, one here, one here, one here. There's probably certainly less than 10 in this region on the map that I'm zoomed in on right now, right? Here's what Helium looks like at this particular instant in time. Everyone's familiar with the Explorer. So what we've got here is a massive opportunity, in my opinion, to help these guys who are interested in forwarding their small packets, which they send pretty infrequently, to where they want it to be on the internet. And my personal opinion, I should be clear, I don't speak for anyone in the amateur radio community. I'm just someone in it who is fascinated by the technology. And there are probably valid arguments to be had about why they prefer to do things a certain way. That's absolutely not a discussion for me to have. I'm interested in potentially an option to tie in the two technologies together. From a purely, this is really cool technical standpoint. So what I was thinking was, rather than having these dedicated stations, which are usually on top of mountains or towers, and they're relatively few, you could also have a device which could send the same information in the same format over Helium and have it go to the same place. So why would one want to do that? I mean, you've got this system, it's working really well, it does its job in an excellent way. Part of the reason I think that might motivate this is that devices like this are really expensive. So this handset, when it was still made, it's not anymore, was about 600 Canadian dollars, 500 American dollars, give or take. It's an expensive piece of hardware. There are only a handful of them like it that are commercially available right now. Due to a fire in the Kenwood factory, they're actually not producing these anymore, to my recollection. And so what people generally do then is they either buy one of the commercial solutions to interact with this network, which is always going to be around $500 or so, or they will take an existing analog radio and plug in some device, which they'll also commercially buy in order to give it that functionality. There's a couple of drawbacks to this nowadays, which weren't really the case back when the system was invented. When APRS started, everybody had an analog radio and nobody had a digital radio. And that's because the technology just wasn't there yet. It wasn't at a commercially viable level. And so it made a ton of sense to be doing analog type modulations to send digital data over radios. And that's what grew this network, and that's why it has the state today. However, nowadays we have technologies like LoRa or even just plain FSK that outperform radios like that, using devices which are this small that you get for $20 off of Amazon, cheaper even sometimes. I think you could probably construct something that's compatible with Helium just as an average person like me for less than 10 American dollars if you source the parts, correctly and we're comfortable with soldering. So there's been this shift over the last 20 years, but especially since the introduction of LoRa, of how we have the option to send short bursts of packet data incredibly long distances. Another reason that you might be interested in marrying these two technologies together in some way is that everybody who's on this map is using at least 5 watts in order to transmit their packets. Most of the people in cars, which are driving through this neighborhood here, for example, he's got buildings in the way, probably. He's definitely on the ground, on the road. He's using 50 watts probably, and that's pretty much what's required in order to make this go. With LoRa, like we all know, you can achieve incredible distances with milliwatts of power, which is a huge draw because it opens up way more, makes the devices more compact, makes them more inexpensive, and you can put them anywhere. And importantly, you can have them on battery power running for years. These are all known things. Here's another fellow who just, they must have just started driving or something like that. He sent out his packet just a minute ago. You can see sort of where he's been driving. Before I keep going on, does anyone have any questions, or should I keep going?
I've got a quick question, if you don't mind.
Yeah, please go ahead.
And so with these, I guess, Helium to APRS, I guess, relays, those would function as bidirectional?
Yeah, and that's actually something which is really important to note about the system is this system is bidirectional, but it has some pretty big caveats in order to get that to work. It depends entirely on the internet side of things in order to be bidirectional. And not all, for example, this one over here, this digipeater over here, this iGate RX only. So this guy has set it up probably with, if I were to guess, he's probably using an RTL SDR dongle to decode these things. He's probably got an antenna on his house or maybe up in a tree or a tower. But if I were in this neighborhood over here, my packets would be sent through this iGate. If someone wanted to contact me or my device through this system, which you can absolutely send, I'll never receive it because this iGate will receive it and go, well, I don't know what to do with that. I can't transmit. And that's the end of that. Whereas LoRaWAN has really solved this quite elegantly and is a fully bidirectional system. So what I did was I went and looked at an open source project, and which I've been contributing to for a little while. What it does is, I'm still screen sharing, good. I can bring it up over here. This is ESP32 LoRa APRS. All it is it's a really simple system that turns your LoRa ESP32 dev board, whatever it may be, into a compatible APRS transceiver. And the critical thing about it that makes it really cool is over Bluetooth, it presents an interface which is exactly the same as this technology would over serial port. There are a number of modern applications like, I don't know if you can see the map on my screen. It's probably a little reflective, that you just get on your iPhone that will pair with a Bluetooth, LoRa, APRS, or ordinary APRS transmitter and give you full access to the system. All of that already exists. People use it all the time. One of the most modern ways to do APRS is to load up the app on your phone. There's at least 2 major ones, many more for a computer, and interface yourself to the system, and you can send traffic in both directions if you're an amateur radio operator. What I think would be really cool is to take this system over here, which does point-to-point LoRa, and add an option in it so that the user could say, well, I want to do point-to-point LoRa because that's great for this application, but I also want to use this LoRaWAN infrastructure. Because right now, if you're an amateur radio operator, say like me, and you think LoRa is awesome and you want to learn more about it, you download this, you flash it to your little dev board, and your experience is going to be, okay, well, I have 2 of these things, they can talk to each other, but unless I set up all the infrastructure myself, it's never going to get on the map, which is the main reason why people use APRS nowadays, in my opinion, is to get their packets from remote locations, carrying their position or their weather data or a short message to somebody else, whatever it may be, into the central system and on the map. If we add to this program a simple facility that, say, optionally transmits packets to Helium, TTN, you could use any network, it could be configurable, then I think the user experience changes completely. Then it becomes, okay, I'm going to download this thing, I'm going to plug it into my iPhone or my Android tablet or my computer. I'm going to load up the programs that I've always used for APRS, and oh, instantly my packets show up on the map. Completely different user experience, completely different audience. And I think a much wider audience, because then it becomes a compelling argument not to buy something like this necessarily, or to buy one of these, but much cheaper that doesn't have the packet capability, because you can reproduce exactly the same use case using hardware that anybody can get off Amazon and program themselves. So what I'm working on right now is, and it's about 87% complete, I'd say, is a fork of this repository, which I've talked with the main developer. We're going to merge it back, hopefully within the next couple of days, that lets you say, okay, well, here's the LoRaWAN network I want to use. And every time this sends a packet in the point-to-point way, it will also send and receive a packet over LoRaWAN. And that's where I want this to go, is to open up this as a huge source of infrastructure that already exists. It's bootstrapped it itself already, which is, I think, one of the great strengths of Helium. Open up that source of infrastructure to a target audience that wants to use it. And the amount of data that they're sending over this modulation and this system is easily handled by Helium. There's one last critical benefit, in my opinion, of having an option for users to marry these 2 technologies together. On the analog APRS system, there's exactly 1 frequency, 1 modulation, and 1 channel. So when you send a packet, it takes about 2 to 3 seconds to do. Not bad, except if you're all sharing 1 channel in both directions for every user on this map, and the range of 1 person, like this digipeater up on the mountain over here, will easily cover probably an area congruent with what I'm showing on the map right now. If you're all sharing that channel, you better not be sending packets too often, or you're going to run into problems. And APRS is, again, a fantastically useful technology, but the modulation comes from an era when things like forward error correction were not easily implemented. There is no forward error correction, no orthogonality between channels. It's 1 step up from an analog system, which is sharing 1 channel. So that means that this fellow, for example, here in the truck, is only going to be sending packets once every 5 minutes, once every 2 minutes at the max. The community will will yell at you if you jam their channel with packets and packets and packets. But there are applications which we know about where it could be useful. Like say you wanted to, this path over here, say you wanted to know what side streets your tracker was going on. Right now, there's no way to get those data. With Helium and with LoRaWAN in general, we've got 8 channels, which are orthogonal across multiple frequencies, all simultaneously. So your channel capacity for sending this information goes from once every 2 minutes to potentially something like once every 2 seconds would be just fine. Or whatever you needed. I mean, if you're interested in optimizing for battery life, you would of course dial that back to a lot and sleep in between. But if you've got an application, maybe like mine for balloons, where what you need is really high resolution data, you could just turn that up and it doesn't hurt the system to do that because it winds up on the internet. So that's what I'm working on right now. What I'd like to do, just to recap, is have it so that an amateur radio operator who's interested in this sort of thing can download this program onto their ESP32, throw in a dev UI, an app UI, and an app key from a common pool, which ham radio operators can just have allocated, and have their packets immediately from the programs that already exist out there be forwarded to and from the system that already exists in both directions. And that's pretty much what I've been working on. I'm hoping to submit a pull request for this this project, within the next week, hopefully within the next couple of days. And it would be really neat to start seeing some Helium and LoRaWAN traffic on their system.
Oh, this is fantastic. Do you mind doing a quick Q&A if folks to field some questions that?
Yeah, absolutely.
Sure,
I am happy to talk about it.
Matthew, thanks for doing this. So it sounds like with the ESP32, it would basically bring the cost down of setting up like a transceiver about an order of magnitude. Is that about right?
Yeah, that's accurate. And this will scale. If somebody were so inclined to do this in a commercial way, which I think could be a viable option, if this turns out to be popular, it'll scale down even more, I'm sure, because the hardware you need to implement this protocol is not sophisticated and available everywhere now, easily implemented in software.
And you had mentioned a moment ago that your radio, the Kenwood, which isn't in production right now, was about $500. And then later on, you mentioned that you could use devices without the packet functionality on them. Are you talking about like the Baofeng or like the $50?
Yeah, exactly. I mean, your
radios,
$10, $20 radios. What a popular way to do this now is to take the word is a little bit out of date, but it's the nomenclature that the community uses, TNC, terminal node controller. Plug it into your analog radio, and then the TNC is a modem, pretty much. This is good, and it works. It has a couple of drawbacks. One of them is that the number of people who make TNCs is not huge. If you want to buy one commercially, there's only a handful of options. Usually looking at at least the $50 to $100 mark last time I checked. You can also implement it in software, but then you need a computer like a Raspberry Pi to run it, and it makes in my personal experience, a bit of an awkward setup. You've got cables all over the place, and you've got audio levels to adjust. This modulation is very sensitive to things like changes in the FM carrier's deviation, which can change with temperature, and it's a pretty fragile way of sending data as it is, because most TNCs will completely fail to decode the packet if even one bit is misaligned when it shows up. There's no forward error correction and no way to recover 2 packets which were sent at the same time either. That's one reason why traffic limiting on this network or rate limiting is so critical. But LoRaWAN pretty much solves all those problems immediately. And you replace a fairly big setup with something that's, something that's just size of one of these dongles, or potentially even smaller, in fact.
Well, that's very cool, because those radios you can get for very, very cheap nowadays.
Exactly, they're available everywhere, and critically, they're also not. The software and community around them is large and it's open source. Whereas the community around, say, something like this, is small, closed source by definition, and you're dependent on one manufacturer, which is absolutely not the case with LoRa and LoRaWAN.
Okay, I've got another question, and this don't laugh at me here, but you had mentioned earlier that on this network, encrypted data is not allowed.
That's correct. So,
and just to expand on that, does that mean that these nodes that you would be building up that act as, the protocol bridge between, I guess, Helium and the APRS network would have to decode at that point, or can you pass encrypted payloads as part of what you're forwarding onto the APRS?
it's a little complicated. Sorry, and there's a couple of different opinions on this. So the letter of the law in Canada and the United States, at least, is that encryption is forbidden on ham radio frequencies, except for special circumstances, like say if you're controlling a satellite or something. There's provisions for that. However, one really common thing to do is to take your app on your iPhone or whatever and send APRS packets to the system over TCP/IP, which is encrypted always and over your network and over the internet, and nobody has a problem with this. So I'm a little bit torn on this. Legally speaking, I don't know what the right answer is. On one hand, I would view it as no different than sending packets over TCP/IP or your cellular connection or any other medium to get to this place, which will definitely be encrypted and decrypted a half dozen times between the source and the destination. On the other hand, since it's going over RF and you are operating as a ham radio licensee while you're doing this, it might draw some criticism, but I think there's a really easy way to just address this right off the bat. And that is to just publish the application keys for a pool of Devi UIs and API UIs that the ham radio guys will use from a list somewhere, and say, look, in principle, if you really wanted to, you could decode these packets now. Nothing we're sending here is private. So I think the argument that it's just the same as sending it over the internet is strong, but I think you can also really reduce potential friction by just, for this particular application, publishing the keys that everybody's using on some website. And this is normally done in ham radio, by the way. It's totally fine to use encryption if the cipher, if the key is publicly available. But it's almost an academic question at that point, because I imagine unless someone was interested in doing some sort of audit of the system or something, they're just going to understand that you're sending the information to a public place, and it just doesn't matter really how it gets sent there. In my opinion, this is my personal take on things, and I'd be interested to hear from folks, especially deeper in the ham radio community than I am, about the compatibility questions, at least when it comes to those kinds of things.
But the problem there, I think, is somebody has to pay for those packets. Somebody has to pay for that
exactly.
data. And that's
So
where the keys come in.
I did a quick calculation. So if I were to spool up a VPS and give it a bunch of data credits and run all of this traffic through it, if everyone on the APRS network were using it, it would still cost like $100 a year, maybe, in order to put their network's traffic through Helium. And because there's just going to be a subset of these guys who will ever use something like this, and their traffic is already pretty infrequent, I think what you could do is just, I'll probably do it just because I'm interested in it, is spool up a server, some data center, and say, look, here's a bunch of pairings of the LoRaWAN parameters. If you pick one from this list, it'll wind up on the map. Have fun. And it'll be cheap. But
I'm a hacker, so I'll flood your system.
Somebody might do that, and we might have to cross that road when we get there.
Yeah,
but I mean, in general, actually, there is a built-in defense against that. If you spam this website with packets, like if you're sending one every second to this server, it'll block you after a point, because they don't want that regardless of how you're sending it. Even if it's TCP/IP, they don't want a bajillion packets clogging up their website. You know, once every 10 seconds, reasonable. 5 is pushing it. But if you just open up some stream, turn on the fire hose, as it were, they'll shut down your call sign. And I mean, that's the other thing too. This is a community run system, and it deals with its own bad actors. So as an experiment, I mean, I'd be happy to host this for a time, but ultimately speaking, I think it would have to look something like, there are other services on this network like SMS Gate, Email Gate, where you can use your packet radio to send SMS messages on the cell network and emails. People will host those and pay for those just because they think it's interesting and the cost is low. I think of this as maybe falling in the same category.
You can't gateway it at that point, though. The honest would be between the device and the Helium console, though, right?
Well, I mean, yeah, that's right. So it winds up in console, and then somehow it's got to be forwarded to this site. So that step will get.
Right. But as far as actually using keys, you know, to send data out, I mean, if you're, well, I know, because your key is still private, right? You're just.
No, it doesn't
Leroy,
sound like
am
it.
I?
It doesn't sound like your keys would be private. Can I, in the console, can I create a device, 2 devices with the same credentials?
I don't think you can you?
No, you can't do that.
So
Okay.
there'd have to be a list, I think, of, you know, my call sign is X, please allocate me some keys that are known to this service that I'm running on some server somewhere that implements the bridge.
Well, couldn't
now-
a custom join server handle that?
Yeah, I think it could, right? That would probably be the best way to do it.
During the join process is where you would provide a private credential, and the people would have to be registered with a system. But
Right.
the join process might, you know, a custom join server might be able to, in addition to our standard credentials, take an additional credential that's checked against a list of registered users. Perhaps, I don't know.
I think that kind of layout also makes sense. For the first, you know, for the first pull request, for the first experiment, where it's probably just going to be me and a couple other guys testing it, I'll probably just run this myself, and we'll share from a pool of, you know, keys that I allocate in the console. But you're right, if this grows, might have to think of another way to allocate this and implement that bridge. Ideally, it would be something that anybody could host on, you know, their Raspberry Pi or their server that just implements this bridge, because this system automatically deduplicates packets. So it's absolutely not a problem on their end to send things multiple times. But that's something I'll have to be thinking about pretty carefully. Again, contingent on how many people use it. As a community, ham radio folks may think this is really weird and completely unnecessary and not want to do it. My opinion, though, is that the benefits are strong, and the argument for giving it a try is strong, even just from the perspective of, well, we've got all this infrastructure, guys, we should maybe think about using it because it already exists.
Oh, that's an interesting idea.
And so in this scenario, I guess you would be maintaining a console organization with devices onboarded on the Helium end of things. And so an individual would then just have to be in contact with you if they built up their own ESP32 device with a radio.
For the moment, yeah, but
Okay.
I'm thinking of a better way to do this.
Well, let me test, man. I'm down.
Awesome, cool. I'll send you I'll toss you a link on Discord when I get that pull request merged. And
Excellent.
you know, it should be pretty convenient. You should be able just to take your, you know, I'm using Haltech LoRa V2s because I like the little OLED screen on them, but I know TTGo and others make these cheap boards. Should just be able to edit a few settings, flash it, and then have your stuff on the map, which would be pretty cool, I think, for this audience. Especially since they can do it faster than they otherwise would. And you know, just one last closing remark. There are a lot of weather stations on this map in remote-ish places. Like here, for example, this weather station, it's going to have a radio on there that's like at least 5 watts. Probably he's running 10 or 20 or 50. And you could implement this sort of thing, I think, a lot smaller, a lot cheaper, and a lot more maintainable, because this is going to have some big solar panels, or it's going to have to be plugged into the grid in order to support that for years and years. I think if you could get exactly the same result using helium and a couple of AA's. And this is something which already exists, of course, but I believe that users of this network might find that application particularly attractive.
Yeah. And the number of already deployed, like in the field weather stations, is enormous. And
yeah,
a very, very small number of those support LoRaWAN at this point. And so,
well, the nice thing is that with this, you could flash it, and since it presents the same serial interface as the things they're already using, it could just be a simple plug in the serial port kind of thing, and you're done.
Yeah, that would be very cool.
So you could convert them over, or you could use both, in fact. And this mountain over here, Pigeon, I know the people who maintain it. There's no way to get to the top except by helicopter. They spend thousands and thousands of dollars every year to make a trip up there to replace big cylinders of propane that power the thing, among other equipment up there. It would be really nice if you could just put a really big, like, lithium thionyl chloride battery bank or something and say, okay, it's good for 50 years. We don't have to go there unless it breaks. So there are applications like that that I feel would be valuable. And I think that's pretty much what I had to say. So with that, I'll stop my screen share and turn things back over to you.
Thanks, Matthew.
My pleasure.
Yeah, Matthew, that was great. I thoroughly enjoyed that, and I'm looking forward to seeing this pull request go through and checking this out.
Well, I'll keep you advised, and it's on my GitHub.
Awesome. And would you mind posting these links into chat here? So
no. Let me do that right now. Sorry. Yeah. So
or either here or over in the Discord happy hour chat. Either way.
I can just post them right now. There's the project, and yeah, I'll just put a description in there.
Now, have you looked at some of the LoRa mesh-based systems? I think we may have discussed them before. But.
I have. Now, this is point-to-point, of course, because I know LoRaWAN is a star topology by design. That's fixed. I've only seen a couple of more sort of hacker academic type applications. Is this something that's been coming out into industry at all?
Yes, a little bit. And actually, I've got a device. It's not in this room right now, but that was sent to me for disassembly. That does a mesh-based LoRa implementation, and it's the only commercial one that I've really seen. But it's weatherized. It's all sealed up into a convenient camping type unit, completely waterproof. But other than that, most of them are open source projects like Meshtastic.
Yeah, Meshtastic is another good example of this. I actually put a Meshtastic node up on. This is sort of a neat story, if it's all right. Let me see if I can quickly find the picture here. Okay, all right. I've got this. I'm just going to share my screen again because this is sort of neat. So this is a old telecom tower from the 70s up on a really big hill in Alberta, Canada, near where I live, that the ham radio guys have sort of taken over from one of the telecom companies. TELUS was really nice and lets them put their stuff up here. These guys contacted me a while ago and they said, hey, we're going up here to do some maintenance on our voice repeaters and things. Do you want to come with? And I said, absolutely. And then I said, what are these two antennas at the top over here? And I said, they look like collinears. Are these on 900 megs perchance? And they said, well, we don't really know. Probably they are based on what we know of this site's history, but they're not hooked up to anything. So I showed up there with a vector network analyzer and plugged it into the, from these things, these two tall antennas over here, the coax coming off of them was like 3 inches wide. I don't know what type that is, but it was this huge armored cable coming in. I bring it down to an SMA, no, I bring it down to an N, and then to an SMA, and then to a UFL, and plug it into my instrument. And lo and behold, you know, the SWR dips right at like 915. So I think it must have been a pager system or something. But there are 2 of these, and while I was there, I put a Meshtastic node on one of them, which is running right now. If I had access to a Helium miner and an internet connection, I think this would have been a really good site to put one on. Maybe someday, who knows? But the point is, this covers like the whole southern half of the province. It's on a hill, everything else is in a valley relative to it. And it's also, I think it's 50 meters tall. The reason I flew the drone up here, besides to get pretty pictures, was actually to measure the height. And I thought, well, we could just, you know, do the high school, you know, algebra way, but this is more fun. So we're going to fly the thing up and read the altimeter. It's like 56 meters exactly. So you know, it's old school. A lot of the things on here don't really work anymore, but their ham antennas do. And these 2 things right at the top are 915. I have no idea exactly what kind of antenna they are. I think if they were collinear, it would make sense. But, you know, maybe somebody else has an idea as to what the deal is. So you see, it was smoky this day, but it goes off to the horizon there. You can see Calgary, you can see Lethbridge. It's all the way over to Saskatchewan from this place. So well, I think someday we got to put a miner up here is what we should do. The place also has an internet connection because up on this hill, not at this particular site, but in its sites adjacent to it. I don't know if I got footage of those. Let me just pan around here. There are other antennas that are much more modern than this. You know, the big fiberglass ones without the guy wires that the telecoms are using? There's like 3 of them that are on the same hill. And so because they're there, everything on this hill has internet. And so it'd be pretty much an optimal location. Yeah, there's one off in the distance. Here's another one over here. I think this is Bell or some other telecom provider. You can see the cellular antennas that are these patches up on there. They probably got other things there that I don't even know about. But the point is that exists, and they make trips, you know, once a year or something up this hill. And someday, I think it would be really cool, at least to put a packet forwarder on there, not necessarily to mine hint, but to just be like, well, it doesn't matter where you are in this province now. Your packets on Helium get through, period. It would be sort of cool, because those antennas, whatever they are, they've been up there for forever, are, you know, well matched in the ISM band. So I was wondering what band they would be on, and it turns out that it's pretty much compatible. It's just pretty hilarious because they probably carried like 500 watts back in their day, and now their huge armored, you know, RF cable is being brought down in increments to a UFL on a tiny PCB. We're putting 50 milliwatts through these things. Half of it's definitely lost in the transfer, but its signal is still amazing in both directions, which makes sense, right? I mean, that's what LoRa is all about. It's got a huge link budget. So you don't need brute force. You don't need power, just good modulation. Thank you. I'm glad you reminded me of that, because that was a fun little project.
Oh yeah, oh, that's slick, man. That's very cool.
Got to go back there, and maybe I should team up with somebody who has a miner in town and ask if they want to put it there as an experiment.
Yeah, absolutely.
I was going to offer that, Matthew.
Yeah.
This is Kevin.
I wanted to show you real quick the commercial device that I mentioned earlier. I don't know if you can see this, but this is called Gotenna is the name of the company. And this is a board that has been stripped of the casing. And it has a PCB antenna on board. And let's see, you can power this guy up. And that's the only interface that you have on the case is just like a one button, and then your LED status. There's 3 LED status lights on the top that show your connectivity, and then it just uses BLE, to a cell phone, like you were talking, to be able to interface and with the device itself. But it allows you to share, I guess, GPS coordinates and text messaging with a meshed group nearby. So,
I've seen those, and I actually know people who have them and who have used them, especially for hiking. And I thought, in recent times, like, the only problem with them is that you get one, you have to buy two of them, because otherwise you're not going to send anything anywhere. It would be super cool if someday a company like that made a product like that, where it's like, oh yeah, it's a mesh. Incidentally, also, you can send it over, all these LoRaWAN networks, so that I think it kind of ties into what we were talking about earlier, where the user experience where you have to set up your own infrastructure restricts it down to like hackers, makers, and people who are interested in radios. The experience where you take it out of the box and then it winds up on some web service, regardless of where you are, that's what people would buy, I think. It would be really neat if, because I believe that those use LoRa as their underlying modulation. It would be really neat if someday someone would come up with that kind of product.
Just FYI, Matt, Gregory and myself both offered to send you a hotspot if you ever want to put one up there.
Well, we'll be in touch. I'll let you know if I'm ever going back up there. And the only trouble with the place is that it's super hard to get up. You got to have like a major 4x4 to drive. I would feel bad if I installed it wrong and then your hotspot was in some prison not working for a year. So, it's a super cool idea. Just if anyone sends me a hotspot to put up there, be advised that if something goes wrong, it'll be a year before I can get it back. But I mean, maybe a packet forwarder would do that.
Yeah, and no, that's not a bad idea at all. Would you have access to the internet backhaul that you were talking about up there?
Yeah, I can make that happen.
That's cool.
I have to talk to them, but I'm sure it could
everyone
work.
on this call is about to say, I think you're probably going to get just a ton of miners in the mail right now.
Well, it would be fine. I am curious. I've never run this simulation, but to load it up in one of the many tools we have to sort of predict earnings or indicate earnings, what that would look like, because I don't know how especially with proof of coverage 11 coming out, how it would react to, like, you have these huge gain antennas on a 50-meter tower that sees multiple cities because it's also on a hill. That could go really, really well. But it would also, I mean, it would be probably among a minority, to be sure, of hotspots up there. Be interesting to see how the newer algorithms treat exceptional cases like that.
Yeah, and talk to Nick over at Helium Vision, or I think I can throw you on my account over there if you want to run some simulations. You're more than welcome to use that.
Sure, that'd be great. Just out of curiosity, it'd be like, well, the next time they're going up there, should we at least drop a packet forwarder to see how that goes? Based on the fact that it works for ham radio through the city of Calgary, I mean, it's gonna witness every hotspot in the city, of which there are like 100 now. So it would be sort of cool to see. And there are two antennas too, I guess. So what you could do is you put a packet forwarder on one and a real hotspot on the other, maybe, and you could do a two-pronged approach here.
Or just put
a real hotspot on both of them. Yeah. Just put hotspots and redundancy, right? They wouldn't get. Of course, crowding them is bad, but I guess in this case it might make sense, because if one failed, then the other's already just there and set up.
Yeah, and a certain degree of redundancy. I would probably put two up if I was gonna do a cell site like that.
How you do it?
Yeah.
Yeah. Well, I'll talk to the ham radio group who sort of controls that site. Doesn't seem to mind. All of their stuff is on 2 meters and 70 centimeters. They have no interest really in 900 megs. So if they would accommodate it, we should, the next time they're up there, I know they're going to make a repair before the snow comes here. I should talk to them and see if we can get something deployed, if for no other reason, just because it would be cool and would be neat to see.
Well, neat. I just noticed that I guess we're at the top of the hour, and I want to be respectful of everyone's time. I understand that sometimes these calls can go on for 4+ hours. So, it's no offense taken if anyone needs to jump off. because this is the Helium Hacks Happy Hour. But Matthew, thanks again for presenting. This has been great, man. And
my pleasure. Thank you for having me. I'm excited to just talk about some of these things that I think are sort of cool that I've been thinking about lately.